Hi everyone, this is Fahim, and welcome to Synergy Prep's SHSAT math video lessons. Now, rates can be defined as how fast you do something, and the most easy example of rates is, say, the speed of a car. And usually, you use the units miles per hour when you look at the speed of a car. So if you replace speed with rate, miles is distance, and hours is time, you essentially get the basic equation for rate, which is rate is equal to distance over time, or R is equal to D over T. Now, you can also take this equation, multiply both sides by T, and you get D is equal to R times T. Now, with this information provided, so long as you have either distance and rate, you can find time. If you had rate and time, you can find distance. And of course, if you have distance and time, you could find the rate. And that's essentially all the information that you'll need in order to solve the one-dimensional rate questions. All right, so let's look at a quick example on D is equal to R times T. So for the first question, on Thursday, Jonathan ran for 3 hours at a rate of 45 miles per hour. How far did he run? So the equation, again, that we have is D is equal to RT. We're provided the amount of time, which is 3 hours, and we're given the rate, which is 45 miles. Plug it in. D is equal to 45 times 3. And we get a total distance of 135 miles. That's it. For the second example, Rafid woke up late for a wedding. Rushing, he jumped into his car and drove at a speed of 60 miles per hour. So I'm just going to write that down. Rate is equal to 60 miles per hour. If the wedding is 210 miles away, how long will it take him to get there? So 210 would be considered the distance. And so I guess we're solving for time, since that's the last piece of the puzzle. So 210 is equal to 60t. If you divide both sides by 60, you get 3.5 hours. Now, these are the simplest questions that you'll get for rates. You will have situations where there will be two objects that are moving simultaneously, and that's the next part of this topic. All right, as I mentioned, the equation that we'll be using throughout this lesson is D is equal to RT. So we originally went over an example where one object is moving in any direction, but what we'll also have is a situation where two cars or two objects in general are either moving towards each other or away from each other. And the equations for both are the same. So what I'm drawing here is two objects moving towards each other. Now, they can of course have two different rates or speeds. So rate A and rate B, and the total distance that they cover, I will just call the total. So the equation that we'll have is, of course, the total distance will equal to the distance of A plus the distance of B. Using the equation that we had, distance of A is equal to rate A times time. Distance of B is rate B times time. So the equation that we'll have for two objects coming toward each other will be the total distance is equal to t times RA plus RB. Now, I would suggest that you memorize this equation. You can, of course, derive it, but so long as you can identify what type of question we're looking at, you don't really need to derive it. You just plug in the formula, you plug in the numbers, and you should have the answer very easily. So the diagram that I've drawn here shows two objects moving towards each other. The same can apply to two objects that are starting in the same spot but are moving in opposite directions. Now if you notice, RA, RB, they're essentially the same thing, and of course the distance between the two will be equal to the distance that each of them moved added together. So we'll be going over a couple of... Let's look at a couple of examples. Number 1, train A is leaving station A at a rate of 50 miles per hour. Train B is leaving station B at a rate of 70 miles an hour. So let's just write those down, right? So rate of A is equal to 50, and rate of B is equal to 70. The stations are 1080 miles apart, so I'm not going to even draw a graph for this. I'm just going to say that the distance between the two, which is total distance, is equal to 1080. And they start moving towards each other at 10 a.m. At what time do the two trains meet? Okay, well, we have our equation to the right side. So dt is equal to time times RA plus RB. We plug in 1080 is equal to t times 50 plus 70, and 50 plus 70 is 120, so you have 120t. So t is equal to 9 hours. So 9 hours after 10 a.m. they meet. So 10 a.m. 9 hours after is 7 p.m. Part 2. How far from station A do they meet? Well, if you look at the graph, or the diagram, sorry, you have station A, you have station B. We don't really know where they meet, so I'm just going to draw an X randomly on the graph, right? So from X to A is the distance that A travels, and from X to B is where B travels. So, how far from station A do they meet? Well, we'll just be plugging in d of A is equal to RA times T. RA is 50. Time is, as we found, 9. Gives us 450 miles. We can do the same thing for dB. It's RB times T, which is equal to 70 times 9, which is 630. If you were to add these two numbers together, we would get that 450 plus 630 does indeed give you 1080 miles. 1080. As I mentioned, the equation for two objects moving towards each other or two objects moving away from each other is basically the same. So let's look at the next example. Amy and Usain Bolt get into an argument at Crown Fried Chicken. Crying, they turn around and run in opposite directions at 3 p.m. If Amy runs at a rate of 12 miles per hour. Okay, so Amy's going at 12, and Usain is running at a speed of 33. How far apart are they after 3 hours? So we have time given, so I guess all we're doing is we're solving for the distance. So dt is equal to t times 12 plus 33. Whoops, I plugged them in beforehand, but you get the gist. So 3 times 12 plus 33, which is 45. So the distance between the two of them is 135 miles after 3 hours. Very easy, right? Yeah, it is. The final question type I like to call the tortoise and the hare question. So if you remember Aesop's fables, you basically have a tortoise and the hare racing. The hare falls asleep and wakes up only to see that the tortoise has a bit of a head start, races after the tortoise, and basically loses the race. So this question is very similar. An object gets a bit of a head start, but the question is always about when does the second object catch up. So we have is object A and object B. Well, if they catch up, that means that the distance that the two objects moved is equal to each other. So dA is equal to dB. But there's a new factor, and that I'll call x, right? And x is the head start. And so say an object 1 starts 3 hours before, well, the head start's going to be 3. If they start 7 hours before, the head start will be 7, etc. The equation essentially is the same. What we have is the rate of A times time, right? But in this situation, object 1 has a little bit of a head start of x, so it's t plus x as time. And object B is just rate B times time. And that's it. That's our final equation. I'm not going to really go over how to derive it because you don't really need to know that. All you need to do is identify the question, identify what you can plug in, and solve for the final variable. So let's look at a quick example. And this one I call tortoise and the hare. So the tortoise and the hare decide to race against each other. The hare decides to give the tortoise a bit of a head start. The tortoise begins the race at 2 p.m. at a rate of 20 miles per hour. So the rate of the tortoise is 20. Now the hare joins the race 3 hours later. So if the hare joins the race 3 hours later, x will equal 3. And runs at a rate of 80 miles an hour. So the rate of the hare is 80. When does the hare catch up to the tortoise? So what we're trying to find is t, right? So let's look at the equation again. R A times t plus x is equal to RB t. So RA is 20. T is what we're solving for. X is 3. RB is 80. And again, t is what we're solving for. If you plug in and distribute, 20t plus 60 is equal to 80t. Subtract 20 from both sides, we get 60 is equal to 60t. And t is equal to 1. So it takes exactly 1 hour for the hare to catch up to the tortoise. And if we look at it in terms of actual time on the clock, the tortoise started at 2 p.m. The hare started 3 hours later, so he started at 5 p.m. And it took 1 hour for him to catch up. So the hare catches up to the tortoise at 6 p.m. And that's it. That's the final question. Now, if we were to look back at all the equations that we've covered, this is what we have. So rate is equal to distance over time, as I mentioned. If you multiply both sides by time, you get distance is equal to rate times time, which is the most basic question to answer. We have two objects moving towards one another, which is essentially T times RA plus RB. And of course, we have two objects that are moving the same distance with a head start of x. So that's it, guys. Those are the three question types for the first type of rate problems. There will be a couple of examples below the video for you to try. And if you have any questions, feel free to contact us at synergy-prep.com. Send us an email, give us a call. If you have any questions, just let us know. Thank you.